Alright, so let's move that concept to the data center. So as you've seen here in the VMware workstation, actually I had an operating system right below my virtual machine. So actually if you noticed in my laptop itself, I had installed Windows 7. Then after that I installed VMware workstation. Then on the top of that I created virtual machines and installed the OS in each of them. When we're moving that to the data center and to server virtualization, we actually don't want to have a host OS. So we don't want to have Windows under our hypervisor or our virtualization software because that reduces our reliability. So what we actually have done, we actually when we're doing a server virtualization, you will notice we will install the hypervisor or the virtualization software right on the directly on the hardware itself. So in the next lesson we will actually show you in the upcoming lessons I will show you how we can install the hypervisor itself directly on the host. So that means there is no OS, there is no Windows, no Linux under the hypervisor itself. Then on the hypervisor I could start creating multiple virtual machines. Each virtual machine have its own hardware specification, where it's actually really consuming a bit of resources of the server. So I could actually go and chunk the resources, the memory and CPU resources of the server into multiple chunks. Each chunk I will be calling it a virtual machine. So let's say I have 10 gigahertz of CPU and 20 gig of RAM on this server. Then this first virtual machine could have 1 gigahertz of CPU speed and 2 GB of RAM. The same thing for the next one. Third one, I could choose whatever configuration I want for that. Then on top of that, I install the operating system. So this one might have Windows, this one have Ubuntu Linux, this one might have Red Hat Linux, this one have a different version of Windows, this one might have a Solaris Linux. So this is basically the concept of virtualization as you see. It's like really easy and simple. So rather than earlier in the traditional architecture or traditionally how application and operating system have been installed in the data center, you actually were buying a full physical box for every operating system instance you wanted to install. So if today you want to install Windows 2008 for one of your client or your users, you go buy a server, physical server, install Windows on it, Windows 2008 for example, then you put the application, give it to that end user. What virtualization allows you to do is you can actually go and purchase that single server, put a hypervisor on top of it. Then after that you can chunk it into multiple VMs. So the first user will only get a VM, and on that VM you install Windows 2008 for example, the application he needs on it, maybe Exchange. The next user when he come in, I don't have to go and buy a second server like I did in the traditional architecture. I could actually just go and expand some of the resources that is not being utilized by the first user, create a second virtual machine out of that with the required resources, then install the operating system on it. Maybe he needed a Linux Red Hat on it, and maybe he's using it for a DNS server, or maybe he's using some HTTP servers on it, or so on. So, and I could repeat that for as many VMs as I needed, depending on the resources available in the physical box running all these VMs, and how much resources each of these users require. Alright, so this picture here as well is kind of documenting the differences again between the two models. The old model, which is what traditionally have been run in the data center, and the new model of virtualization. So earlier, as we mentioned, you had a single OS per physical machine. So you buy a physical machine, you only installed one OS on top of it. The other thing that's used to happen as well, you could actually, technically you could install multiple applications on the same operating system. You weren't doing that because you were usually worried of conflicting between your applications. So imagine if you were actually desiring to install Exchange and Microsoft SQL. Well, you couldn't actually install them on the same machine because they will conflict directly in the traditional model. So if you install just Windows 2008 on a physical server originally and you want to try to install Microsoft SQL, then a Microsoft Exchange in the same machine, they will conflict and that doesn't work. And that has led to mainly as well having only a single application being installed per physical server. So in the traditional model, for every application you want to import a physical server. For every operating system instance that you need to install, you want as well import a different physical server. With the new model where we run virtualization, now you actually every time you wanted a new operating system instance or to install a new application, you just create a new virtual machine, which will carve resources of the physical box. You don't actually have to go and buy a second physical box, as long as you have enough resources in that physical box to span more VMs. So this first VM here, that could be running Windows 2008 and the application on it could be Exchange. The second one could be running Windows 2008 as well and running Microsoft SQL. I could have another third VM in there which is running Linux Red Hat as well, running my HTTP servers and so on. So I could actually done multiple VMs on that as long as I haven't run out of resources. So as you can see, I could utilize my server more wisely. As long as I have enough resources in the physical server, I could go and span more instances as required, unlike the original or traditional architecture where you actually had the operating system and application totally tied up to the physical box itself. The other thing which is nice as well about the virtualization model, that's the application and the operating system is not tied to the physical box as much as they were in the in the traditional model. So in traditional model, your operating system were totally aware of what hardware you have in the box. So actually, if you wanted to move your operating system and application that was installed in this physical box to a different hardware configuration, it used to be a lot of hassle because you have to change all the drivers that were used. Where in the new model with the VMware technology and with virtualization, you actually have the operating system having its own standardized virtual machine hardware. So it's a virtual hardware. It's not really corresponded to whatever hardware installed in the box. So this virtual hardware, you could move it easily, or this virtual machine, you could move it easily from this box to a different hardware configuration, because the operating system itself, like Windows, is not aware of what's the physical box look like. It's only aware of the virtual hardware being assigned to it. So this is making moving such applications and operating system or the VMs much easier from one box to another than it used to be in the physical world. The other thing which is nice as well, with actually the improvement of CPUs and the evolution of it, we have so powerful CPUs today that almost there is no application that could utilize the full power of a CPU or how big of a box that you can get today in the market. There's few applications that could utilize a lot of CPU power, but like let's say about 90% of the application in the market today, they're not going to be able to utilize that. So with the traditional model, a lot of time you're wasting a lot of that CPU power. You're just installing that CPU and you're probably utilizing 10 to 20% of it. Where in the new model, as we could actually now have multiple applications, multiple instances of the OS as well on the same box, we can actually better utilize the CPU. So while this is here, I was able to run a single instance of the OS and a single application per that CPU, I'll probably be utilizing 10% of the CPU. Where here in this model, as I could have multiple applications running in there, I could utilize up to 90% or more. So I could better utilize my CPUs than I ever were possible with a traditional model. Okay, so another thing which is important to mention is the anatomy of the virtual machines. So each virtual machine is totally independent of the virtual machines running next to it in the same host. So actually, it doesn't matter what OS I install in the first virtual machine, and and whatever I install on the second one. They're totally independent. I can install Windows on this one. I can install Linux on this one. I can install Unix in the third one. So they're totally independent. The other thing, there is no connectivity between these VMs, unless actually if I actually go to the networking level and make them connect. So I control what's connectivity between them. So if I decide in the network level, VM1 doesn't see VM2, then they never see each other. And whatever happened in VM1 will never affect what happened in VM2. So let's have a very nice anatomy. So if actually there is a virus or something affecting VM1, that doesn't mean it can get by any way or by any means to VM2. It have actually to travel, like a virus or so on, had to travel to from a particular VM to another VM through the network, just like it would done if they were totally two separated physical boxes. The other thing which is nice about as well the virtual machines that we're providing is actually you can run a totally unmodified operating system, totally unmodified applications on it. So as you saw, like actually I installed just Windows 2008 as it is from the like I got the CD from Microsoft, just put it in and install it. So I don't have to change anything. It's installed exactly as you would install in a physical box. On top of that, I went and installed the application exactly the same way. So you don't have to change the way you install your operating system or application. You don't have to do any special crazy customization to get it running in a virtual world. You just actually install them the same exact way that you always did in the physical world.